Hi everyone. So today I have a really interesting problem for you, and we're going to be learning about recurrence relations. So we're going to look at what recurrence relations are, how to solve some basic recursions, and not only that, we're also going to look at the method of induction, which is probably one of the most common methods for solving methods for like proving formulae, right? So for example, if you have a formula and if you want to prove that it holds for all values of n or whatever, then induction is probably the easiest and one of the most common ways to solve it in subjective exams. So I hope you enjoy it. This is the problem number 9 from the AMC 12A in 2019. And in this video, we're going to learn about recurrence relations and how to solve recurrences. The method of induction is probably the takeaway from this video. Then we have certain book suggestions for the AMC and of course, a similar but challenging problem.
This video is sponsored by Cheenta.com. Since 2010, Cheenta has trained thousands of students from all around the world in mathematical Olympiads, physics Olympiads, computer science and informatics Olympiads, ISI CMI entrances, and research projects for school and college students.
So this is what they have given to us. A sequence of numbers is defined recursively as x1 is 1, x2 is 3 by 7, and they give us a formula for xn for n greater than or equal to 3. And they've asked us to find out the value of x 2019. Now, first let's see what a recursion is. Like, what's a recurrence? So, well, if the nth term of any sequence or any series can be written as a composition of its previous terms. So, for example, xn can be written as 3 times x minus 1 plus 7 times xn minus 2. This is a recurrence, right? The terms are in a way recurring in terms of their previous terms, right? For example, if I write xn as 7 times xn minus 1, this is also a recurrence. And you might have heard of the Fibonacci sequence, which is probably the most common recurrence sequence out there. And it's also a recurrence. And what they've given to us, xn is equal to xn minus 2 times xn minus 1 divided by twice of xn minus 2 minus xn minus 1. This is also a recurrence, with the first two terms specified, of course. Now, they want us to find x 2019. Now, if I just directly plug in n is equal to 2019 into this, I'll get something like this. Okay, now this can obviously not be solved because we don't know what the values of x 2017 and x 2018 are. So, well, what do we do over here? So, whenever you see these complicated or these large terms, on one side, what you can do is essentially analyze certain simple cases. So maybe try to figure out the values of x3, x4, x5, and just see if you can observe certain patterns over here, right? So let's try to find out the value of x3. What would x3 be? x3 would be nothing but x2 times x1 divided by 2 times x1 minus x2, right? And if I just plug in the values of x1 and x2, I would get 3 by 7 divided by 2 minus 3 by 7, right? So essentially x3 would be 3 by 11. Now that's great. Now if I try to find out x4 would be nothing but I believe x3 times x2 divided by twice of x2 minus x3. Now again, if you can just try and find out the value, you would get 3 over 15. Similarly, you can try finding out the value of x5 and you would get 3 over 19. So what I can observe is there's actually a pattern forming over here. Let me just write it out a bit more clearly. We found x3 to be equal to 3 by 11. We found x4 to be equal to 3 by 15. We found x5 to be equal to 3 by 19. So if you can actually see the denominator is increasing by a factor of 4, right? So essentially the denominator is in a way forming an arithmetic progression, right? Increasing by 4 in every term. And we can find out the nth term of this. So xn can be written as 3 divided by 4n minus 1. Right, that's pretty standard. And you can actually check that this holds true. If you just take x6, you would get 3 over 23, which is actually what you would get if you plug in these values as well. So now we can actually figure out x 2019 fairly easily. That would be 3 divided by 4 times 2019 minus 1. And that comes out to be 3 divided by 8075. This will be 8075, right? So p plus q would be nothing but 3 plus 8075 which is 8078. Now, yes, the AMC has 4 options on it, so you can just take this and move forward. It's a time-bound exam. You need to take into consideration that as well. But if this is a subjective exam, you would have to kind of like prove that this formula holds for all n, right? So this formula we just deduced from observation. You would essentially have to prove that this formula holds for all n, right? And how do we do that? We're going to use a method called as induction, right? And this is a fairly common method. You can use this to prove a lot of formulae, and the method is kind of simple. So this is how it goes. So we assume that the formula holds for all n less than or equal to m, and we essentially then define xm minus 1 to be equal to 3 divided by 4m minus 5, and xm would hence be 3 divided by 4m minus 1. How do I figure out the value of xm minus 1? Well, you have this formula of xn over here. Just replace n with m minus 1. And you would essentially get something like this, right? Now, in the formula, they had given us xn is xn minus 2 times xn minus 1 divided by twice of xn minus 1 minus xn minus 2, right? Now, if I just replace n with m plus 1 over here, I would get xm plus 1, right? And what would that be? That xm minus 1 times xm divided by what would be the denominator? It would be twice of xm minus xm minus 1. And that's great because we know the values of xm and xm minus 1. And if I just plug that back into this, I would get something similar to this. 3 divided by 4m minus 5 times 3 divided by 4m minus 1. In the denominator, we have twice of minus. Okay, that's great because essentially what we are doing right now is we are finding out the value of xm plus 1 in terms of m, right? This comes out to be 9 divided by 6 times 4m minus 1 minus 3 times 4m minus 5. You can actually check out this actually works. And xm plus 1 would hence be 9 divided by 24m minus 6 minus 12m plus 15. So xm plus 1 essentially comes out to be 9 divided by 12m plus 9. And if I just divide the numerator and denominator by 3, I would get xm plus 1 is 4m plus 3. Or in other words, xm plus 1 would be 3 divided by 4 times m plus 1 minus 1. I think that is a point where you stop your induction. So you essentially prove that xm is equal to 3 divided by 4m minus 1. And you also prove that xm plus 1 is equal to 3 divided by 4 times m plus 1 minus 1, which actually holds true. Hence our induction is true, and hence we have proved the formula, right? So this formula is actually holds true for all n. And so essentially that was the method of induction. That is how you would prove this formula in a subjective exam. Obviously, for the extent of the AMC, you can just figure out the formula by observation. Just take the option and move forward. But I hope you really enjoyed the explanation of that. Now, coming on to some book suggestions for the AMC, we have Mathematics Can Be Fun by Yakov Perelman, Mathematical Circles, The Russian Experience, Algebra Can Be Fun by Yakov Perelman, and Excursion Mathematics, Challenges and Thrills of Pre-College Mathematics, and of course, Elementary Number Theory by David Burton. Now, after that, we have a very similar but challenging problem. So again, we have defined a sequence of n terms of non-zero real numbers, satisfying xn is this given expression for n3, 4, and 5. Now, if you actually just remember the problem that we just solved, this expression is the same that we had kind of used in this problem, right? So we've essentially already formulated the value of xn. Xn, you can actually find out the value. It will be 3 divided by 4n minus 1, right? It's essentially the same setup. What I want you to do is I want to establish necessary and sufficient conditions on x1 and x2 for xn to be an integer for infinitely many values of n. Now, obviously, this value of xn I had found out given the value of x1, x2. Okay, that's obviously the condition. But over here, I want you to establish the necessary and sufficient conditions on x1, x2 for xn to be an integer for infinitely many values of n. So yeah, I hope you understood the problem. And as usual, if you make any progress on it or if you're able to solve it, let me know in the comment section. Until then, I'll see you later. Thank you very much and bye-bye.
Cheenta programs are designed for students who are passionate about mathematics. And they are personalized with one-on-one training, individual evaluation, and remedial sessions. The reason Cheenta students are successful over the last 10 years because they are taught by mathematicians and real Olympiads from leading universities in India, United States, and Europe. Some of our students come back to teach at Cheenta from Oxford, Cambridge, Harvard, MIT, UCLA, ISI, CMI, IITs, TIFR, and IISc. For more information, visit cheenta.com.